A very good morning to all my dear students. Welcome back to the 5th class of the online session 2020-2021. So I am back again with the same chapter, magnetic effects of electric current. Okay, and today I am going to teach you the last topic of this chapter, that is domestic electric circuits. Domestic electric circuit. Domestic means circuits which are used mainly in our houses. Okay, so we are going to see this. Before I start with the domestic electric circuits, I hope all of you have gone through the electric generators, your AC generator, your DC generator, which is based on electromagnetic induction. I hope you have understood what is a commutator, okay, all these things that we had done yesterday, and how you are going to find out the direction of the current in case of the induced current, in case of electromagnetic induction, that is by using Fleming's right hand rule. Okay, so what happens initially, I am very much sure that initially you are going to face problem, okay, because if you don't place your fingers properly at the right direction, then you are not going to get your answers properly. Otherwise the topics are very easy and very simple. You keep on trying, keep on practicing. I am sure you are going to get through it. Okay, so I start with the last topic of this chapter, domestic electric circuits. And this topic is quite interesting, We know that, electricity in huge amounts that comes to our houses is actually generated in the power stations which are located at the outskirts of the cities, isn't it? And they come to our houses by thick either copper wires or by aluminium wires. Okay, so now let's see, there are two types of wires which actually enters our houses. Okay, there are two types of wires which enters our houses. One is marked L. Look at the diagram very carefully. Okay, this is the circuit diagram of a domestic electric circuit. I have represented it with the help of a diagram. Try to understand this. L is one wire and N is another wire. So there are two wires which are actually entering our houses. L stands for live wire. L stands for live wire. Live wire is actually red in color. This live wire is actually red in color. Okay, so that we can, once it enters the houses, the plastic covering, the insulation is actually red in color, so that we can make out which wire is for what purpose. This live wire has very high potential of 220 volt. High potential of 220 volt. Okay, and N is another wire which is known as the neutral wire. This neutral wire has a potential of 0 volt. Neutral wire has a potential of 0 volt, and this neutral wire is black in color. It has a plastic insulation which is black in color. So whenever you see a red wire, okay, it is actually the live wire that you have in your houses. The circuit having the red connection, the red wire is the live wire which is having a very high potential of 220 volts, and here you have the neutral wire which has a potential of 0 volt and is black. It has black plastic insulation, okay, plastic covering. Now, the difference between these two, the potential difference between the live wire and the neutral wire is 220 volt, because potential difference means 220 minus 0, that comes to 220 volt. Got it till here? Okay. Now, initially, before it enters the houses, they don't have any plastic insulation. Okay. What happens is, when the live wire, before entering the house, it is connected to a, the main fuse. F1 is actually the main fuse. Then you can see after the fuse, the live wire and the neutral wire, both of them, they enter the meter. This is the main meter of the house. What is the purpose of the meter? It is going to show how much of electrical energy is consumed in your house. Okay, how much of electrical energy is consumed in your house in kilowatt hour. How much units we have consumed in one particular month. Okay, so it will show you the reading, and this meter box is provided by the electricity department, electricity supply department. Okay, so both the wires, they enter the main meter. After entering the main meter, these wires, they enter, now they have got the insulation and they enter the main switch. The main switch of the house. All of you have seen the main switch of the house. If you have to do any kind of repairing work or anything, we switch off the main switch, isn't it? To do the work, to cut off the supply of the current from the live wire. So this is S stands for the main switch. The live wire is again connected with another fuse, F2. F2 stands for consumer fuse. Live wire is again connected with another fuse which is known as the consumer fuse. So you can understand that so many fuses are there because it is carrying very high amount of potential difference of 220 volt. Okay, so it enters your house. And look at the neutral, which is of 0 volt. This is also entering your house. There is another wire which is marked E. Can you see? It is coming down right from the main meter and it is entering, it is getting, deep inside the earth. It is embedded. Okay, and there is a copper plate and this whole wire is embedded deep inside the earth. Okay, and this one has got initially no insulation. Now once it enters this main switch, okay, from here the insulation starts, and the color of this earth wire, E stands for earth wire. This color is green in color. Earth wire is green in color. So this earth wire, the purpose is to do earthing, to discharge the high amount of current if it suddenly flows through the circuit, so that we are protected from electric shocks and all. Okay, so the purpose is to do earthing. So E is the live wire which is green in color. Mind it, live wire is green in color. So by looking at the color, we can easily differentiate which one is which wire. L, the red wire, is the live wire. N, neutral wire, is black, and earth wire is green in color. Okay, so earthing is very necessary. So this enters, so this is the earth wire. So the three wires are entering, and remember the circuits that we have in our houses. Okay, oh, another thing I forgot to tell you, this particular fuse F1 has 50 ampere. Okay, its capacity, its current is around 50 ampere. Okay, now once these three wires, they entered the houses, in our houses, there are two types of circuits. One is the lighting circuit, another is the power circuit. Lighting circuit has a fuse of 5 ampere. Lighting circuit has a fuse of 5 ampere and power circuit has a fuse of 15 ampere. So lighting circuit has a fuse of 5 ampere and power circuit has a fuse of 15 ampere, 15 ampere. So what is the purpose of this? Lighting circuit are those circuits where those appliances which consumes less amount of energy, less amount of electricity, they are connected to the lighting circuit having a fuse of 5 ampere. For example, the bulbs, the tube lights, okay, fans, then you have the radio, TV, all these things are connected with the lighting circuit, and those devices or appliances which draws huge amount of current, for example the refrigerators, then your geyser, your electric kettle, electric iron, the power consumption, the electricity consumption is more, so they are connected to the power circuit having a fuse of 15 ampere. Apart from this, another thing is that the circuits are usually connected in parallel. In class 9 you have done what is the advantage of having a parallel circuit over a series circuit? In parallel circuit, we know the voltage remains the same throughout the connections, throughout the circuit, okay? And if there is a fault, if there is damage or anything in one of the circuit, it will not affect the other circuit. Okay, so on only that particular portion you need to repair it. There will be no effect in the other circuits. So that is one advantage of parallel circuit over series circuit. So most of the appliances, in fact all the appliances, are actually connected in parallel, and each of them, they have separate switches. Okay, apart from this, these are about the the fuses, different fuse that we have. Apart from this, those appliances which draws huge amount of current, those who are connected to the power circuit, they individually they have fuses which are present inside the appliance. Okay, so if any problem is there, supposing in your micro oven, so the problem will be with the micro oven only. It is not that your refrigerators and other things, there will be no problem in those things, since all of them are actually connected in parallel. Remember, the live wire has got a switch. We always put a switch in a live wire because the live wire actually carries lots of current, isn't it? As a result, what happens is, this live wire, we need to, when we switch off, we have to break the connection of the live wire so that no more current is drawn to the circuit. Okay, so we have to break the connection there. So it is very important that we keep a switch along with the live wire, okay, to break the connection so that the circuit becomes incomplete and no current can be drawn in that circuit. So what is the purpose of having this earthing, the green wire? The green wire is a protection, Sometimes it can happen that we have an electric iron, and you have seen the body of the electric iron is metal case. Okay, so there are three wires which are present in an electric iron: the live wire, the neutral wire, and the earth wire. The live and the neutral wire are connected to the heating element, but the earth wire is connected with the metal case. The earth wire has a connection with the metal case. The reason is that by chance, if the live wire comes in contact with the metal case, since it is a metal, it can conduct electricity, and when you are touching the electric iron, huge amount of electricity can flow through your body and you can get severe shocks, electric shocks. In order to protect from that, the earth wire is actually connected to the is kept in contact with the metal casing of the electric iron, so that even if there is any problem, what will happen? The electricity will flow through the earth wire and deep inside the earth. So as a result, we will be protected from getting electric shocks. I hope you can understand the importance of having earth wire. Earth wire is actually going to discharge all the current. By chance, it can happen that the plastic insulation of the live wire and the neutral wire is torn by chance, okay, and the live wire, which is having a high potential, comes in contact with the metal case of the electric iron. If it comes in contact with the metal case of the electric iron, huge amount of electricity can flow through our body, and we know human body is also a conductor. So it is advised that we stand on any wooden plank or wear rubber slippers because they are insulators. So they will not allow the current to flow through our bodies, because the circuit will be incomplete or broken circuit in that case. Otherwise, if the whole body is in contact with the earth, what will happen? Huge amount of current can flow through our body. To avoid that, the metal casing is kept in contact with the earth wire, that is the green colored wire. And you must have seen the 3-pin socket. There is a plug. This electric iron has a plug, and the plug has 3 pins, and these 3 pins are inserted inside the 3-pin socket like this, a 3-pin socket. So one is actually earth, another is neutral, the another is live. So that is how, what is the importance of your earth wire. Got it? So this is the structure of your domestic electric circuit. I hope you have understood. This is F1 stands for main fuse, which has 50 ampere capacity of 50 ampere. Okay, then comes your main meter, main switch. F2 stands for the consumer fuse, and then you can the two main divisions of the circuit in our houses are lighting circuit and power circuit. Got it? And how will you identify which wire is what? By looking at the color of the plastic insulation. If it is red, it is light. If it is black, it is neutral. If it is green, it is earth. Okay, so this is your domestic electric circuit. So here we were speaking about fuse. Many a times I have told you about fuse, and F1 stands for the main fuse, F2 stands for the consumer fuse, and all those. And they have, each of them have different capacities. You can see like the main fuse, it has around 50 ampere of current it can bear. So like that they have different capacities. Now what is a fuse? A fuse is basically a very thin wire which is tin plated. Okay, tin plated, a copper wire which is plated, tin plated, and it has a low melting point, and it will melt and break the circuit when huge amount of current will try to flow through the circuit. So it is going to protect the circuit from catching fire, short circuiting, all those things. Okay, so basically the purpose of the fuse is to break the circuit. That means once the fuse breaks, the connection breaks. The circuit becomes an incomplete or broken circuit, and current can no more flow through the circuit. So it prevents from short circuiting, and this is the symbol of a fuse. This is the symbol of a fuse. You have already done it in your junior classes. So this is the symbol of the fuse, and the purpose and the function of fuse, I hope it's clear to you all. Okay, and remember, appliances like microwave, refrigerators, which draws huge amount of current, they have their fuses embedded within them. Okay, so this is the purpose of your electric fuse, to basically protect the circuit from catching fire and all. Okay, so what is short circuiting? There are two things I told you just now. One is short circuiting, another is overloading. Short circuit means by chance it can happen that the plastic insulation of the live wire and the neutral wire breaks, and they come in contact with each other. That time suddenly huge amount of current can flow through the circuit, and this can raise the temperature to a very high temperature, and this can catch fire also. This is known as short circuit. Then what is overloading? If you have a socket and you connect too many plugs which draws huge amount of current, you are connecting to one particular socket to draw current. So that time also it can catch fire because of overloading. If you are trying to draw too much of current from one particular point, that can also cause fire, and it can also cause some kind of accidents. Okay, so these are the purpose of fuse. So it will prevent or protect a circuit. So I hope you have understood the chapter. This particular portion was very easy one, very interesting. Okay, domestic electric circuits. Go through the chapter and read the chapter, solve your worksheets, okay? And especially those rules, your right hand rule, Fleming's right hand rule, Fleming's left hand rule, Maxwell's thumb rule, all these things, please practice this as much as you can, okay? And we have covered the whole chapter. Go through the chapter, read it, and keep on studying, okay? So thank you all of you, and have a good day.